Good morning, boys and girls. It's Monday, May 11th. We're starting something new today. We're going to learn how to solve systems of equations using elimination. Last week we used substitution. The week before that we used graphing. This week we're going to use elimination. And this is actually going to take us probably 2 weeks because you can eliminate by adding and subtracting, but you also can eliminate by multiplying. So we'll do multiplying next week. We'll just focus on addition and subtraction this week. Today is Monday. It's Alex Day. I ask that you get your 30 minutes in your 3 lessons and you watch my video where I introduce the topic. Tomorrow there will be a 7-3 practice available on Edulastic, and I will also post a video explaining how to do the problems in that practice, and I call those my walkthrough videos. Thursday, you'll have a quiz on Edulastic, and I'll do a walkthrough video that will be live on Thursday. Okay, I did get a couple of Pinterest posts today, just for fun. Here, I never thought the comment, "I wouldn't touch him with a 6-foot pole," would become a national policy, but here we are. Yeah. I love these. And teacher, being a streamer or a YouTuber isn't a real job. Teachers now. I always wanted to be on YouTube. This is fun times. Okay, so when we are solving systems of equations with addition and subtraction, here's what we're trying to do. Our goal is to eliminate one of these variables. We can't solve for x and y. We want to solve for one or the other. These two equations are set up nicely. You'll notice that the x's are lined up, the y's are lined up, and the constants are lined up, which is nice. If those weren't lined up, we'd have to move them around. Okay. When we look at a problem like this, we know this is an opportunity for us to eliminate using addition because there are two terms that are exact opposites of each other. -8 and +8 are opposite, which means that if we add these two equations together, the y's are going to drop out. Okay, so that's what we're going to be doing here. We're going to go ahead and let me switch over to pen. We're going to go ahead and we're just going to add these two equations together. All right, 9x plus 10x is 19x. -8y and +8y equals nothing or 0, or they just cancel each other out. So then we put the equal sign. We're not going to write anything for the y terms here. 7 minus 26 is -19. Well, now it's pretty darn easy to solve for x. We just divide both sides by 19. And we now know that x is -1. Once we have our x, we just pick one of these equations, and it doesn't matter which one we use. We pick one equation. Let's say I want to use 9x minus 8y equals 7. And we substitute -1 in for x. Minus 8y equals 7. And that gives me -9 equals -8. Oh, no, not equals. Oh, it's a Monday. It's starting off like a Monday. Right to pen. Okay. -9 minus 8y equals 7. To get 8y by itself, I need to get rid of the 9. So I add 9 to both sides, which gives me -8y equals 16. Dividing both sides by -8 gives me that y is -2. So our final solution is x is -1 and y is -2. See? I think this is a really easy way to solve. It's very convenient when you look at two equations and you see that immediately they have two exactly opposite terms. Let's do another one. Again, here we have two equations and we have opposite terms. So we have a -1x and a +1x. When you see that, you know all you have to do is add the equations together to get the x's to drop out. -x plus 1x is 0. I'm not even going to write 0. -9y minus 10y gives me minus or -1y equals 8 minus 8 is 0. Well, We could multiply both sides by -1 if we want to make y positive, but it doesn't matter what you multiply 0 with, it stays 0. So y is 0. Now we pick one of the equations to substitute y. I'm going to go with this first one, negative x plus 9 times 0 equals 8. That gives me negative x, 9 times 0 is 0, equals 8. To get x to be positive, we multiply it times -1. You could also divide it by -1, same difference. And we get x is -8. So that means that our solution is x is -8, y is 0. Super fun, right? I'm loving it. Okay, in this example, this spoiler alert, something weird's going to happen. We do have opposite terms. We have a negative 4x and a positive 4x. But notice we also have a negative 8y and a positive 8y. How is that going to work out? Well, if we add these two equations together, those cancel out and those cancel out. What's left on the left? A big fat 0. On the right, we have 5. 0 does not equal 5. So, because this gives us a false statement, this is an example of a no solution system. It's just not going to work out. This is another example of a weirdie. Here, everything's going to cancel out here, all right? Negative 2x and positive 2x gives us nothing. Negative y and positive y gives us nothing, so we have a big fat 0 on this side. But on this side, we have negative 14 plus positive 14. Well, negative 14 plus positive 14 is 0. So this is a true statement. And when you have a true statement, you have infinite solutions. All of the points that solve the one also solve the other. There is no point of intersection. They basically are the same line. And I could prove that to you. If I were to multiply every term in this first one by -1, I would have 2x plus y equals 14, which is exactly what the second equation is. Okay. So that's how to solve systems with addition. You just simply add the top to the bottom. It's a super efficient and fun way of solving these, and I love it so much that when I get to these subtraction ones that they want me to use, a little off screen there. When I get to these subtraction ones that they want me to use, my plan is really to, I'm going to use subtraction, but I'm going to end up adding because I like that better. Okay? It's like when we're adding negative numbers, don't we keep change switch so that we can add instead of subtracting? Nobody likes to subtract. Okay, so I know this is a case where I'm going to have to subtract. Notice that we have a positive 2y and another positive 2y. Those are not opposites. They're the exact same thing. So in order for us to make them opposites, what I tell my students to do is pick one of the equations and multiply every term by -1. What that's going to do is it's going to change the sign. -1 times -4 is +4. -1 times 2 is -2. And -1 times -28 is +28. Now I can add them because now I have opposites. So while I am subtracting, I'm putting a minus sign out here. Reveal wants you to go through in your head and go, oh, okay, -4 minus -3, and nobody wants to do that. Just if you see two terms that are identical, pick one equation and multiply everything by -1 so that it's set up for you to add them. All right, here we're adding a positive 4x with a negative 3x. That gives us a positive 1x. These two now will cancel each other out. And a positive 28 and a negative 25 gives us a positive 3. So now we know x is 3. We pick one of the original equations and substitute 3 for x. I'll use the top one. -3 times 3 plus 2y equals -25. Now I'm ready to solve for y. -9 plus 2y equals -25. Add 9 to both sides. Gives us 2y equals 16. And if we divide both sides by 2, we get y is 8. So now I have x and I have y. Cool, right? One more example of using subtraction. Notice again, we have two terms that are identical. We need them to be opposite. So what we're going to do is pick one of them, and we're going to multiply every term by -1. Ooh, why did Mrs. Williamson pick that first one? Well, there was more negativity in it to begin with, all right? So by multiplying this one by -1, all of these become positive. And I like positive, okay? Now that we have opposite terms, we have a plus y and a minus y, we can add the two equations together. 2x plus 3x is 5x. The y's drop out. And positive 24 and positive 16 is 40. Divide both sides by 5. And we have that x is equal to 8. Pick one of the equations. Now, maybe you're looking at this one after I multiplied everything by 1 going, there's a lot of positive numbers in there. Could we just use that one? Sure you can. All right, we can do that. Let's use 2x plus y equals 24. I like that. We know x is 8, so we have 2 times 8 plus y equals 24. That gives me 16 plus y equals 24. And then I subtract 16 from both sides, and I get y is 8. Oh, well, okay, so x and y were both 8. Weird, but okay. 8, 8. Just kind of threw me off there for a minute. I'm like, did I do that right? I hope I did. Okay. Now let's look at what happens when we have a need to subtract, but spoiler alert, things are going to go south. Okay. We need to have opposite terms. Okay. These are the same. These are the same. In order to fix this, we would multiply one of the equations by -1. It will give us positive 2x, positive y, and -2. Okay. Well, now we can add them together because we have opposite terms. This gives us nothing. This gives us nothing. Oh my gosh, we have a whole bunch of nothing on the left. But we also have 2 minus 2 on the right and a whole lot of nothing on the right. There's a whole lot of nothing in that problem. This is a true statement, so it has infinite solutions. Okay. I bet you can guess what's going to happen in the last example. Okay, well, let's see. Again, we have identical terms. So when we have identical terms, we multiply one of the equations by -1. That will make this positive, and this positive. Now that we have opposite terms, we can add the equations together. But this gives us 0. This gives us 0. So on the left, we have nothing. And on the right, we have 3. But since 0 is not equal to 3, this is a false statement. And that means that there are no solutions to this system. These two equations will be parallel to each other. So that's how you add using elimination with addition. And, well, they want to call it subtraction. I call it, let's multiply everything by -1 and make it addition. Yeah, okay. So that's what we're going to be doing this week. Tomorrow I'll post a video where I do a walkthrough of the Edge Elastic assignment that you'll find that will open up automatically tomorrow morning. And in the meantime, I hope you guys have a great rest of your Monday. Make sure you get your Alex minutes. And I miss you all. Bye.